Okay, in the previous video, I challenged you with this problem. If a projectile is launched from the bottom of an incline and the incline itself is angled as indicated with the symbol phi, and the launch angle is indicated as theta, then how can we determine the distance along the incline, right? What's a formula that expresses the value of d, provided we just know v, theta, and phi? So the answer is given. It's just up to you to prove that from fundamentals. So if you're watching this video, you're either checking your work or you need a hint. So feel free to see how, at least one way that you can derive this solution. So our distance d needs to be labeled here. So how about this? We treat horizontal and vertical motion as independent of one another. Well, this velocity at an angle can be broken into components. So there's the total velocity v, and here we have v cosine theta, right? And this is v sine theta. So if I know a distance and a corresponding velocity, I should be able to figure out time. So the time it takes until the projectile makes impact here is equal to the horizontal displacement divided by the horizontal velocity. So the time the projectile spends in the air is x over v cosine theta. Okay, so that's a study of the horizontal motion. Now, as far as the vertical motion is concerned, delta y equals v naught yt plus 1/2 at squared. Now let's say up is positive, down is negative. Then delta y can be replaced with just y. That's what we're calling it here. And v initial in the y direction is v sine theta. And then we just found that time is x over v cosine theta. And we need to add to that 1/2 times. So if g just represents a magnitude of 9.8 meters per second squared, but the acceleration is downward, then I better call this negative g. And then we've got time squared. So x divided by v cosine theta quantity squared. So let's try to simplify a little bit. We've got step 1, step 2, and step 3. We can say that y equals x tangent theta. Sine theta over cosine theta gives us tangent. And then minus g x squared. Okay, we got the g, we've got the minus, we've got x squared divided by 2 v squared cosine squared theta. Okay, now let's go to step 4. Let's see, what we're trying to find is an expression for d. So somehow we need to relate the quantity d with x and y, but all we have here is a right triangle, yeah? So, SOHCAHTOA. I guess x would be equal to d times cosine of phi, and y would be equal to d times sine phi. So let's make that substitution. Instead of calling it y, we'll say d sine phi. And instead of calling it x, we'll call it d cosine phi. Then minus g x squared. So g d squared cosine squared phi divided by 2 v squared cosine squared theta. Now every term has a d in it, right? So if I divide everything through by d, that d cancels, and it changes the d squared to just a d to the first power. So step 5, let's do this. Since this is negative, we can bring this whole term to the other side of the equation, and just a little rearranging here, we get g times cosine squared phi, all divided by 2 v squared cosine squared theta, all multiplied by d. So that's a representation of all of this brought to the other side of the equation, equals, and then we were left with cosine phi, and of course then I had to bring sine phi to the other side of the equation, so minus sine phi. And then I just need to do a little cross multiplication then, right? We're going to isolate for d. So d is equal to 2v squared cosine squared theta times the quantity cosine theta minus sine phi. Oh, let's see. Time out. Did you catch my mistake? I replaced x with d cosine phi, but I forgot my tangent theta. Okay, so that all goes together here. So let's see. That means I left out my tangent theta where? Here. Oh, yeah. Which means there's still a tangent theta here, huh? Okay. Okay, so I cross multiplied this, so it shows up here. This term is in parentheses, that's still here. And then, then I need to divide both sides of the equation by this term. So divided by g cosine squared phi. Okay, step 7. What if I did this? What if I divided both numerator and denominator by cosine phi? I get d equals 2v squared cosine squared theta times the quantity. So I'm going to divide the top by cosine phi. That means this goes away, and then I have a sine phi over cosine phi. And if I then divide the denominator by cosine of phi, it just changes it and it gets rid of that squared. Okay, so I have 2v squared cosine squared theta times tangent theta minus sine over cosine is tangent, so minus tangent phi. Don't confuse theta and phi, two different angles. And then all of this divided by g cosine phi. Okay, is that what we were trying to prove? Yeah. We've got it. That's the expression we were after. 2v squared cosine squared theta, 2v squared cosine squared theta, tangent theta minus tangent phi, tangent theta minus tangent phi, all over g cosine phi. Yep, nailed it. Sorry about this mistake with the tangent theta being left out. Hopefully you got that. Let's just double check and see if this is a reasonable answer. There's no reason why we shouldn't be able to apply this equation to level ground. Now the only difference between level ground and an incline, on level ground we say we've got an angle theta and a velocity v, and on an incline we say we have a velocity v, an angle theta, and an angle of phi. So the only thing about level ground is it just implies that phi is equal to 0 degrees. So if we take the solution d equals 2v squared cosine squared theta times tangent theta minus tangent phi, all divided by g cosine phi, we just need to plug in 0 degrees for phi. Okay, well, tangent of 0 is itself 0. And the cosine of 0 is 1. So we end up with d equals 2v squared cosine squared theta times tangent theta, all divided by g. Now keep in mind that tangent is the same thing as sine over cosine. So I can cancel that cosine with the squared here, and now we're left with d equals v squared times 2 cosine theta sine theta. 2 cosine theta sine theta, and then all divided by g. And as we said the first time we derived the equation for launching projectiles across level ground, if you remember your double angle formula, 2 cosine theta sine theta is the same thing as sine of 2 theta. So this just gives us back the familiar formula, d equals v squared sine 2 theta over g, which is exactly what we expect if phi is 0 degrees, as it would be for level ground. So looks like we got it right.